1 will become 0, 0 will become 1. Okay, so if the any Boolean function, now we are going to study about the Boolean functions of algebra. Okay, Boolean algebra. So the any logic function can be designed using these three gates. That is AND gate, OR gate, and inverter. That is the NOT gate. And other than these three, so without we are drawing the logic circuit. Logic circuit and circuit diagram. Logical circuit. Okay. So the logical circuit can be designed using more than one gate. That is the AND gate, OR gate, not in multiple times. We can't design the using single gate, that is the OR gate or NOT gate or AND gate. We can't design the any logic circuit using only AND gate, only OR gate, only NOT. The combination we are designing for the any logic function or any logic digital circuit. And the two more gates are there. That is the NAND gate and NOR gates. The NAND is the complement of AND gate. The NOR is the complement of OR gate. Okay, so the any Boolean function, the any logic expression can be designed using these three gates AND or NOT. Okay, the three gates are compulsory, or at least two gates are compulsory to design the logic circuit. But coming to that is the main drawback. Now coming to this NAND or NOR gate, the any Boolean function can be designed using only NAND gates. Only NAND gates without using any other gates. The any circuit. For example, if you want to write the logical, what is that? A C is equal to A plus B. If you want to design the circuit for the C is equal to A plus B expression, the NAND gate is enough to design the circuit. How we can design, we'll understand later. Okay, so now R, you can use the single NOR but multiple NOR gates, multiple NAND gates. Using the single gate, we can design the any logic function. So that's why this NAND and NOR gates are called universal gates. What are the universal gates? NAND or NOR gates are called universal gates. Using the single NAND gate, we can design the any circuit in the digital. That is the known limitation. We can design the any circuit. Okay. For example, AND gate is there. AND gate is there. Okay. Now, AND gate is there. AND gate without AND, how we can derive the NAND AND? You can see what is the AND expression. What is the AND expression? Boolean function. A dot B simply AB. Now we can see for this. Now we can take input. Input you can take here A, B. So this expression, the AND gate symbol is this. A, B, output is AB, right? Output is AB. Now, AND gate we are using the NAND gate. Sorry, this is the NAND gate. Okay, what is the meaning of this? How many minimum inputs are required for the NAND gate? 2 minimum. So that's why we are taking the input 1, input 2, but the 2 inputs I am taking the common input. So that's why I am making the short. Okay, here also 2 inputs short. Now what is the output of this NAND gate? What is the NAND gate output? X Boolean function. If the NAND gate is the AB, then what is the output? AB bar. ఇక్కడ ఏం రాయొచ్చు? ఒకటే ఇన్పుట్ ఉంది కదా. So A bar. Next here B bar. Next here A bar dot B B bar, whole bar. ఓకేనా? ఎక్కడి నుంచి వచ్చింది ఇది? ఇక్కడ ఏంటి? ఇన్పుట్ A, ఇన్పుట్ B. ఇక్కడ ఇన్పుట్ A bar, ఇన్పుట్ B bar. So A bar, B bar. Whole bar ఉంది ఇక్కడ. That whole bar is. Now how we are getting this A bar dot B bar to whole bar to AB? Will understand after studying the Boolean algebra properties and theorems and De Morgan theorems. Okay, so that's why the NAND and NOR gates are called universal gates. Okay, and similarly using the NOR gate also we can derive all the gates and any Boolean functions. Now Boolean algebra. You can remember this. A bar dot B bar whole bar. ఆ ఎక్స్ప్రెషన్ నాకు ఏం రావాలి? AB రావాలి. AB వస్తుందా? A ప్లస్ వస్తుందా? వీళ్ళ C. A plus B. This is not. Okay, now Boolean algebra. What is algebra? General algebra. Define anybody can define the general algebra. What is algebra? In mathematics, what is algebra? Algebra definition. Algebra. The algebra is the mathematical operation that can teach the arithmetic operations, addition, subtraction, multiplication, division. That is A square plus BC plus C square, any expression. Those are called algebra. And here algebra Boolean. Boolean means binary, zeros and ones. So this Boolean algebra is the branch of mathematics. The Boolean algebra is the branch of mathematics, and it deals with the logical operations with the logical values. What is the logical operations? AND operation, OR operation, NOT operation, XOR operation, and with the binary variables or binary values, the 0 and 1, and variables are A, B, C, and so on. The binary values are 0s and 1, and these are binary variables. So for this binary variables, we can assign either 0 or 1. For this also we can assign either 0 or 1. But in the mathematical algebra, we can assign the A plus B. For A, any value 0 to infinity, any value we are assigning, and B also we are assigning any decimal value. But here we are assigning if you are taking any variable in the Boolean algebra, then that we can assign only the two values. The two values are either 0 or 1. These are the binary values, digital values. Okay. Now, so that is now here the similar to mathematical algebra, the Boolean algebra also having some theorems and postulates. What is the meaning of postulates? What's the difference between the postulates and theorems? Both are used as a formulas. Theorem and anything. Theorem can be used as a formula. So what is the theorem and what is the postulate? Theorem should have the proof. Proof untene ante మనం x తీసుకుంటే దాన్ని x అని ప్రూవ్ చేయాలి. then only that is called as a proof. Theorem. Okay, any theorem should have the proof. Okay, that is the theorem. The postulates or doesn't have the theorem, we have to blindly have to accept. Okay, now the postulates are Boolean algebra. It deals with binary values, binary variables. The binary values are 0 and 1. The binary variables are, you can take A, B, C, and so on, any English letter. The binary variable is any English letter, and for this each binary variable we are assigning either 0 value or 1 value, either 0 or 1. Next, and also it deals with the logical operations. The Boolean algebra deals with the binary values, binary variables, and logical operations. These logical operations are plus. What is the plus? Or operator, dot, and operator, and complement, not operator, and then XOR operator. The basic operators are and, or, no, only three. Using three, we are deriving the NAND operation and all other remaining logical gate operations. Okay. So OR operator, AND operator, this one, only three. XOR ante enti ikkada? XOR can be written as AB dash plus A dash B. So ikkada em undi operator, and here not, or, not, and. Only basic three operators. That is, AND operator or logical operators are AND or not operators. Okay, so these are the Boolean algebra now, and similar to our mathematical algebra, this is also having postulates or axioms. It is having axioms or postulates. These axioms or postulates are doesn't require proof. The proof is not required. We have to blindly accept. Okay. Now it is having some blind postulates. That is, you can take the AND axioms. The AND axioms are 0.1. 0.1. Dot means, what is the dot here? AND operation. What is the 0 and 1? 0. Is it required any proof for this to accept the 0.1? Already we know that is derived from the AND gate, AND statement. Based on that statement, we are drawing the logical table, truth table for AND operation. From that truth table, we are deriving this. So for this, the proof is not required. And 0.0, first 0.0 really 0, 1.0, 0, 1.1, 1. That is these are axiom 1, axiom 2, axiom 3, axiom 4. And similarly, the OR axioms are 0 plus 0, 0 plus 1, 1 plus 0, and 1 plus 1 is 0, 1, 1, 1. Right? So that is OR axioms. So for this axiom or postulates also, the proof is not required. And not is 0 equal to 0 bar is equal to 1, and 1 bar is equal to, these are all our axioms. Now, similar to the mathematical algebra, here also we are having some laws, the Boolean laws. First one, undo laws. What is undo law? Now we can take the one variable a dot 0, a dot 1, a dot a dot a bar. Don't sit the blind. Ideally, can answer this. A is the variable. For that a, you can assign either 0 or 1. Assign either 0 or 1. Now, what is the a dot 0? 0. See, you can assign the a for 0, 0 dot 0, 0. A equal to assign a equal to 1, 1 dot 0. So, the any value of a, the a dot 0 becomes 0. So, you have to remember this. This is the one theorem or one law. Okay, next. A dot 1. A dot 1. Now tell me the a dot 1. If a is equal to 0, 0 dot 1 is the 0. If a equal to 1, 1 dot 1 is a. Now what is the expression for that a dot 1? A. If you are assigning the a equal to 0, 0 dot 1 is the 0. What is the 0? A equal to a value. If a equal to 1, 1 dot 1 is 1. So that is a. So that depends a. Now a dot a square. A dot a is the a square, not square. That is the AND operation. 1 dot 1, 0 dot 0, 0, 1 dot 1, 1. So that is equal to a. Next, a dot a bar. This is important. A dot a bar. Right? Now you can assume the a is equal to 0. What will happen here? 0 dot a bar. A bar and 0 bar. What is the 0 bar? 1. 0 dot 1, 0. 0. Next, a equal to 1. 1 dot 0. Value? So whenever if you are having in the Boolean function a dot a bar or b dot b bar or c dot c bar, that means the any function, the variable with AND operation with variable with complemented variable there, simply you can write 0. For example, I will write a dot a b c a bar. What is the value? All a b c are Boolean variables. What is the value? 0. ఇక్కడ 0 ఉంది, ఇక్కడ 1 ఉంది, ఇక్కడ a ఉంది, ఇక్కడ a bar. So that will become right. You can remember. Now R laws. R laws. What is R laws? Same. A plus R operator. A plus 0, a plus 1, a plus a, and a plus a bar. A plus a bar. Endama. A plus 0. A equal to 0 unte 0 వస్తుంది, 1 unte 1 వస్తుంది. So that expression is written as a. Next, a plus 1. Irrespective of a value, the output is 1. 1. A ante 0. 0 plus 1, 1. A equal to 1. 1 plus 1, 1. So irrespective of a value, the a plus 1 is equal to 1. Next, a plus a, 2a. Not 2a. R operation. That is the not plus operator. Addition operator. That is the R operator. Next, a plus a bar. A. Assume the value 0 plus 0 bar 1. 0 plus 1, 1. Next, assume a equal to 1. 1 plus 0. So wherever here, for example, a plus b plus c plus. What is the value? A plus a bar ante 1. So remaining danpe a value unna gani will get the 1. So these are the very important. This one and this one, then this. Okay. Now these are the general theorems or general laws for the AND operator and OR operator and another law similar to mathematics. Mathematics ఇంకేం ఉంటాయి మన లాస్ ఇవి ఉండవు. What is the mathematical law? చెప్పండి ఏదైనా ఒకటి. Commutative law. Commutative law. Tell me, what is the commutative law in the mathematics? Commutative property. Commutative property. మంచిదే. రెస్పాన్స్ తక్కువ వస్తుంది. లాస్ట్ వాళ్ళ సెషన్ వాళ్ళు మీటింగ్ లో బిజీగా ఉన్నారు. వాళ్ళ మీటింగ్ లో మీరే. Okay, what is the commutative property or commutative law in the mathematics? A plus B is equal to B plus A. A plus B is equal to B plus A and A dot B is equal to B dot A. You can write it any way. A dot B or B dot A. A plus B or B. So the same commutative property can be applicable to our Boolean algebra also. Then what is the next one? After commutative, associative. Associative law. What is associative law? A plus B plus C is equal to A plus B plus C. And similarly, A dot of B dot C is equal to AB dot. Okay, now that is the associative. And another one, distributive property or distributive law. What is the distributive law? చెప్పండి. A plus BC is equal to A plus B is equal to A plus B into A plus C. ఏమా చూడండి ఒకసారి. దాన్ని ఎవాల్యుయేట్ చేయండి. A plus BC వస్తుందా? ఫస్ట్ ఏంటి? A into A. Where is it? Okay. A dot A. A వస్తుంది. Next A dot C. ఏమవుతుంది అది? ఎంతమ్మా? A plus BC. చెప్పండి ఏమొస్తుంది? ఇది కరెక్ట్ ఆ రాంగా? Wrong. Okay. Now I will take the RHS. What is RHS? I am saying this one is the distributive law. Now we can take the, this is the theorem. Okay. Now we have to prove LHS is equal to RHS or RHS is equal to LHS. Now we can take the LHS. What is the RHS? Now we can take RHS. What is RHS? A plus B into A plus C. Similar to mathematical evaluation of expressions. Similarly, here also you can evaluate the expression A dot A. plus A dot C plus A dot B plus BC, B dot C. Now A dot A can be written as A plus AC plus AB plus BC. Now you can take the common one. What is the common term in the common letter? A. So now you can take the A common here. 1 plus C plus B plus. Now what is this expression? 1 plus C plus B. R law. You can see the R law. A plus 1 is equal to. అంటే ఇక్కడ 1 ఉంటే ఇక్కడ variable e variable k you can assign the any value will get the 1. So now you can use the R law for this one. So A dot 1 plus BC, that is equal to A plus BC is equal to LHS. So the theorem is proved. Okay, so now this is the distributive property. ఇక్కడ theorem అవసరం లేదు, చూడగానే మనం చెప్పొచ్చు associative property or commutative property. Okay, so for the distributive property this, so LHS is equal to RHS. So wherever A plus BC is there, you can write A plus B into A plus C, or A plus B AC is there, you can write A plus BC, vice versa. Okay, so that is the distributive property. And the other one, అది using ఏమి చేశాము, plus operator. Now the second one is, this is the one distributive property 1 and the distributive property 2. Em raichama actually A dot B plus C is equal to AB plus C. Okay. So these are the properties. And one more important property is there, that is the demon. Many properties are there, but are not required for you. Okay. Now, the any properties, any theorems are there, then simply you can use this concept. What we studied till now, you can use that concept and you can get the proof for the any theorem. Okay. These are the basics are enough. Now, the important one is there, that is the De Morgan theorem one. Sorry, distribution and the property theorem 1, theorem, right? Next, and the important. Can note down. Notice contract. Yeah, you can note. Proof for the distributive property. Distributive property 1. The next one is important theorem for entire Boolean algebra. That is called De Morgan theorem. The De Morgan theorem. The De Morgan theorems are important to evaluate the Boolean expressions or Boolean functions. The previous మీకు ఏం చెప్పాను, AND నుంచి tan ఎలా derive చేస్తున్నాం అని చెప్పాను. అక్కడ ఒక ఎక్స్ప్రెషన్ ఉంది. So we are stuck with there. Why? Because we don't know the De Morgan theorem. After studying the De Morgan theorem, we can evaluate that expression. That is the giving the AND operation or not using the NAND gate. Okay, now we'll go to the reverse. Okay, now I'm erasing. See, yesterday morning onwards we are discussing that is there any issues in that discussion? Is there any difficult topics or any other? Feel out the Okay, you can read anything. Okay. Okay. Over. Now, the De Morgan theorem. Right? The previous axioms and theorems and laws are similar to our previous mathematical expressions and theorems. Now, this is a completely different, the new expression or new law in the Boolean algebra. This is not available in the mathematical. This is not applicable to mathematical algebra. Okay, the De Morgan theorem 1 is A dot B whole bar is equal to, what is that expression? Expression number A dot B. A which of A use that expression? Huh? That is the which gate expression, output expression? NAND gate. The NAND gate expression, NAND gate is inputs and bubble. Here without bubble we are getting AB and bubble is there, that is the indicator NAND gate. So the NAND gate expression. Now, if the NAND gate expression is there, that can be evaluated like this. Okay, so the De Morgan theorem 1 is A dot B whole bar is equal to A bar plus B bar. And the theorem 2 is A plus B whole bar is equal to A bar dot and plus. Okay, reverse. A bar dot B bar is equal to A plus B whole bar. Now, how we are converting this? I will give the simple statements. Okay, now the steps to get the De Morgan theorem. First one, if the whole complement is there, apply individual complement. అదే చేసాము ఇక్కడ హోల్ బార్ అంటే ఏం చేసాము A bar చేసాము B bar చేసాము. Now the second step is convert under to R and R2 and right, and next one convert 0 to 1 and 1 to 0. Using these three steps, we can get the any De Morgan theorem. The three steps. First, you can convert the whole bar to individual variable bars and AND operator to OR operator or OR operator to AND operator. And if any zeros or ones are there, you can change 0 to 1 and 1 to 0. Right. These two are very, very important. Now, I say the NAND and NOR gates are the universal gates. How that NAND and NOR are universal gates, we'll discuss using this De Morgan theorem. Okay, now you can see. Now, why the first one is the AOI logic. AOI means and or inverter. Any Boolean function can be evaluated using the three gates, the AND gate, OR gate, and the inverter. Now that is the difficult, and we are requiring the more different types of gates are required now. But NAND, if you are using the NAND or not, in any expression, the any gate can be evaluated using this NAND and the NOR gate. For example, OR gate. So how the OR gate expression can be evaluated using NAND gate? What is the OR expression? A plus B, right? Now you can see how this expression is giving the OR expression. I am taking the one NAND gate, NAND gate, NAND gate, NAND gate 1, NAND gate 2, NAND gate 3. Right? Now I am applying the 2 input NAND gate, and the common input I am applying to the for gate 1, gate 2. That is, output of this one is the A bar and the B bar. What is this gate expression? Input is the A bar dot B bar, and due to this complement, whole complement. Now you can evaluate this expression. Apply the De Morgan theorem. AB whole bar. AB whole bar. So AB whole bar is equal to A bar already plus B bar. This is E variables class. Listen, everyone here. Now next A bar plus B bar. A bar plus B bar. So same variable Rashano, and will become R, and whole complement you can apply to. Now complement of complement gives complement of complement. For example, you can do the first 0 complement, 1 complement. So if you are applying the 2 times complement, you will get the same value. So anyway, the 2 complements are there. Simply you can write. Now what is the R expression? What is the final expression? So now the R gate is replaced by the 3 NAND gates by arranging these 3 NAND gates in this way. Okay. Now coming to the AND gate. What is the AND gate expression? AB. Right? Now you can see what is the output of this first AND gate? NAND gate A dot B whole bar, and A dot B whole bar. Then complement of complement nullified. AB. So the same expression here. And you can tell me the NOT gate. NOT. How many gates are required for NOT? Same. Here also you can take the one NAND gate and the single input NAND gate. Then first input entama A bar, and here A bar whole bar is equal to A వచ్చింది A bar రావాలి. చెప్పండి. That's it. Single NAND gate. Single NAND gate gives the NOT expression. If you are using the 2 gates, then you will get the original value. Original function, that is the 2. If you are using the 2 NAND gate, that is the acts as a buffer. Okay. Now you can take the simple expression. For that simple expression, we can draw the logic circuit. How we are going to draw the logic circuit, you can see now. Anyone wants this? So the any De Morgan theorem can be derived using these three steps. Okay, the step one, apply the individual complement. Second one, convert under to r to and, then convert 0 to 1 and 1 to 3. అంటే ఇక్కడ ఏంటి, డాట్ టు ప్లస్, ప్లస్ టు డాట్. And one more similar to this De Morgan theorem, and one other theorems are there. There is a duality. Duality అంటే just I will explain. The duality అంటే ఏంటంటే ఇక్కడ కాంప్లిమెంట్స్ అప్లై చేస్తున్నాం కదా, అక్కడ కాంప్లిమెంట్స్ అప్లై చేయం. కాంప్లిమెంట్ we are not disturbing the complement. Simply ఈ స్టెప్స్ వాడుతున్నాం. అంటే అండ్ నుంచి ఆర్ చేస్తాము, ఆర్ నుంచి అండ్ చేస్తాము, 1 to 0 చేస్తాము, 0 to 1 ఎక్సెప్ట్ కాంప్లిమెంట్. కాంప్లిమెంట్ చేస్తే అది De Morgan theorem. కాంప్లిమెంట్ చేయకుంటే దట్ ఈస్ డ్యూయాలిటీ థియరమ్స్. ఓకే, now Boolean logic diagrams. Now we can take the one Boolean function f is equal to ab plus ac plus a bar b plus c bar b. Okay, now we need to draw the logic circuit. That is the Boolean function. The computer cannot we need to draw the logic circuit using AOI gates. Now we can implement, how many variables are there? 3 variables. Now we can take the 3 variables A, B, C. Okay, now what is the first operation? What is the first expression? AB. What is the relation? What is the which operator we need to use? Logical AND operation, AND gate. Okay, what is the output of this gate? AB. Next, what is the next expression? AC. So what is the AC? AND or relation? AND relation. Now we can take C. Take A eక్కడ ఉంది? I will take individual తీసుకోవాలి, ఇక్కడ నుంచి తెచ్చుకోవాలా? What is the meaning of this curved shape? Connection, bypass చేసినట్టు. Okay, so now this is AC, and then next one A dash B, and here A, this is the A. A ఏముందమ్మా? Dash. How to get the dash? Use the NOT gate, then C. Okay, so now this expression is A dash C, and the last one is A dash B. Next one is C dash B. Where is the B? B is the as usual same, right? This, and C is, you can take the dash NOT gate. So this output is B C dash. According to the commutative property, can write the C dash B or B C dash. Okay, now what is the next one? Next item. What is the plus? OR gate. Now we can take the one OR gate. This is the logic diagram for the given Boolean function. Okay. Okay. Draw this. Similarly, if the any Boolean function they are giving, you can draw the logic circuit. So why we are studying this logic circuit? The next topic is the combinational circuit. That's the full adder and half adder. So in that we are going to draw the this type of logic circuits. That logic circuit gives the summing output and the carries. How many inputs for the OR gate? How many inputs? 1, 2, 3, 4. 4 inputs. Right? That is the 4 input OR gate. The minimum inputs are required 2, for the maximum any number. But in the physically, the 2 inputs OR gate is the different IC. For example, the 2 input OR gate and the 3 input OR gates are different. 4 inputs OR gate are different. And IC numbers function for the design different గా ఉంటుంది. ఇప్పుడు మనకు 4 ఇన్పుట్ లేదనుకోండి ఎలా చేయాలి? We don't have the 4 input OR gate. Then how to draw the logic circuit for that? Only 2 input మాత్రమే ఉంది. అప్పుడు ఏం చేయాలి? You can take the one OR gate for this expression and this expression, and here one more OR gate. ఈ అవుట్పుట్ వస్తుందా? మళ్ళీ రెండింటిని can join the OR gate. So using the 3 OR gates, we can evaluate this expression. This is the 4 input OR gate. The 4 input OR gate. Now you can see the 3 input or 2 input OR gate. Radha. Huh? Now using that 2 input OR gate, you can take like this. Sorry. The final expressions. First we are summing these two and these two, then we are summing this two. That is using AOI logics. How many different gates are there? OR gate is there, AND gate is there, NOT gate is there. So this logic circuit is called AOI logic. Now this AOI logic we need to convert into NAND logic. Only NAND gates use చేసి చేయాలి. ఎలా చేయాలి? This concept is not required, for the knowledge purpose I am saying. ఇక్కడ AND gate ఉందా? In this AND gate you can use the NAND gate. I draw the logic NAND equivalent to NAND gates, right? You can replace this AND gate using that AND gates, NAND gate. Here also same, and here also you can replace with the NAND gates. Replace, not directly replace, the equivalent to NAND logic for this AND gate. Then that will be converted to NAND logic. But the concept is not required. This is enough for use. Okay, now okay, now heading the combinational circuits. The combinational circuit is, you can take the one black box, and here inputs and inputs and here logic. The combinational circuit output depends on only present inputs. If you are changing the input combination, you will get the output. Similar, the one example for this is AND gate. Okay, now you can apply the 0 1. What is the output? What is the output of AND gate? Apply the 0 1 to the AND gate. What is the output? 0. So now this is the one combinational circuit. The all logical gates are example for the combinational circuit. The combinational circuit means the output is affected whenever the inputs are modified or changing. Whenever the inputs are changing, the output will be immediately will reflect. That is called the combinational circuit. Now we can apply the 1 ohm, 1. The output is 1. Immediately, whenever you are applying the changing the input, the immediately we are getting the output at the output side. So that type of circuits are called the combinational circuit. And this is also one of the combinational circuit. This box is the combinational circuit. So in that box, any logic circuit, any logic operation. Okay. And the logical circuits are two types. One is the combinational circuit, and the second one is the sequential circuits. Only basics are there for your according to your syllabus. Okay, so that is the combinational circuit and the sequential circuit. The sequential circuit will discuss later. Now the combinational circuit is the output is reflected whenever the inputs are applied. That is the combinational circuit. Now the example for the combinational circuits are all logical gates and all Boolean functions. This Boolean function logic circuit also one combinational circuit. Okay. Now in this combinational circuits, we are designing the adders, half adder and the full adder. Okay. Now the full add, the first one is the combinational circuit. Examples are logic gates. The examples are logic gates and adder circuit, and in this adder circuit, half adder and full adder. Half adder circuit and full adder circuit, and subtractor, then half subtractor and full subtractor, then decoders and encoders and multiplexer. Simply that can be abbreviated as MUX. These all are the combinational circuits. Now we are discussing this adders. So adders are two types. adder, the Boolean adder or the is of adder and full adder. The first one is of adder, okay. So in this is the combination of adder is the combinational circuit. So in this combinational circuit, the inputs are two inputs we are taking, that is the A, B, and because general if you are adding the two numbers, what are the results can be expected? If you add the two numbers, the logical or in the algebra, the mathematical algebra, what are the results we are expecting? Not zero. Results. What type of results will get if you add the two numbers? Type. What is the result type? Okay, based on the value, we'll get the positive value or negative value. This is the type. What the results can be, will get after the addition operation. Okay, now we can take the one example. 29, 35. What is the 9 plus 5? 14. Hello, Riley. 4 here. 5. What is 1? What is 1? Into final value 1 only. Why not here? 1 is 81. What name under? What is the name of that one? Huh? What is the name under? 4 is the sum. One name under. Do you know the carry? What is one here? Carry. Okay. Carry. So if you are adding the two numbers in the digit, Boolean or in the mathematical algebra, we are getting the two results. The results are 4 and 8. Sum, carry. Okay. So how many inputs are there? Two inputs. Using these two inputs, we are possible input options are 0 plus 0, 0 plus 1, 1 plus 0, and 1 plus 1. Right? Now, what is the 0 plus 0? What is the sum value and what is the carry value? And here you can remember the everyone here. If you are adding 9 plus 2, and the 11. Okay. 9 plus 8, 17. So 1 here and 1 is the carry here. When we are getting the carry in the decimal addition, epudu carry vastundi? 4 plus 3, how much? We are at the 4 plus 3. What is the value? 7 is the sum. Okay. 5 plus 4, 9. 6 plus 5 plus 6, 5 plus 5, 10. 9, 5 plus 4 వరకు అంటే 9 వరకు సింగిల్ డిజిట్ సమ్ వచ్చింది. ఆఫ్టర్ 9 2 digit number of in the 2 digit number, the first digit is the summing value and the second digit is the carry value. So when we are getting the carry? After 9. After summing value 9, we are getting the carry positions. Okay. Now come to the binary values. What is the 9 here? 9 in the decimal. The 9 is the maximum symbol value in the decimal number systems. After maximum symbol value, then the carry will get. Okay. 6 plus 6, 12. 12 is the sum value. 1 is the carry. We are at the 12 answer. And similarly, in the binary also, what is the maximum symbol value in the binary? 1. 1 tarata em ostadi? 2 ostadi. When 2 is not available in digital. So what is the 2 equal to binary value? 1, 0. So 0 is the sum value and 1 is the carry. You can remember now. Or you can remember this. 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 0, and carry. Right? 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, and 1 plus 1, sum 0, carry 1. Now we can add 0 plus 0, sum 0. What is the carry in this addition? No carry means you can keep the 0. Next, 0 plus 1, 1, carry is 0. Next, 1 plus 0, sum is 1, carry is 0. Next, 1 plus 1, sum 0, carry 1. Sum 0, carry 1. See here. 1 plus 1 is equal to 1 is the carry and 0 is the sum. Okay. Now this is the truth table for half adder. Half adder means that only the block diagram of half adder is the two inputs A, B, and the outputs are sum and carry of adder. HA. H stands for half, A stands for adder. Half adder. The two inputs and the two outputs. Now for this half adder sum and expression, we are going to get the Boolean function. Using that Boolean function, we are drawing the logic circuit, and based on that logic circuit, we are designing the circuit and we are making the half adder IC. That IC will give the summing result, 2-bit addition result for the any combination. Okay. Now for which is the here, for which input combination we are having the sum value 1. Now we can write the sum expression for half adder. Now this input combination is called A bar B bar, and this input combination is called A bar B, and this input combination is called B bar, and this one is A. Here the 0 means while drawing the logic circuit, high means 1 and low means 0, and 1 means on and 0 means off. Okay, 1 means on, 0 means off, high means 1 and low means 0. Now here 1 ante uncomplemented value, 0 ante complemented variable. So A equal to ఏముంది ఇక్కడ 0 ఉంది. So A bar dot B bar, A bar B, A B bar, A B, for which input combination the sum value is 1. Which input combination? Here we are getting the sum, and here we are sum, and here sum. What is the expression? Sum is equal to A bar B plus A B bar, and simply this can be written as, what is the equivalent expression for the A bar B plus A B bar? A XOR B. The sum S is equal to A XOR B, or simply can keep the A bar B plus A B bar. No. Now, and similarly for the carry, you can write the expression. What is the carry? For which input combination we are giving the carry is 1. A equal to 1. Now, so the logic circuit for the half adder is one XOR gate and one AND gate. That is the logic circuit. Now, you can apply the any input combination here. You can take the one input, any one. Shall I take the 1 0? Input values. Apply the A value and B value. Assume the any value. A equal to 1, B is equal to 0. Now, ఇక్కడ ఏమొస్తుందమ్మా ఇది 1 ఇది 0 డిఫరెంట్ ఇన్పుట్స్ ఆ సేమ్ ఇన్పుట్స్ ఆ డిఫరెంట్ ఇన్పుట్స్ సో అవుట్పుట్ ఇస్ 1 నెక్స్ట్ ఇక్కడ 1 0 ఇక్కడ 1 ఇక్కడ 0 అవుట్పుట్ ఇస్ sum 1 carry 0 verify the table sum 1 carry 0 similarly you can apply the any input this gives the summing input summing value and the carry value. And here we are separately placing the sum value and the carry value. Okay, so that is the half adder circuit. Yes, no doubt. Next combination of circuit is the full adder. The difference between the full adder and half adder is in half adder we are using only the 2 inputs and full adder we are using 3 inputs. The difference between the half adder and the full adder, see here, if you are adding the 2 numbers A and B, assume the tell me the A number of bits. Shall we take the 2 or 3? Shall I take the 3? 3-bit number. A is the 3-bit number and B also the 3-bit number. Okay, 101 and B is the 010. Now we can add the 2 numbers. First, 1 plus 1. How many numbers we are adding? How many numbers? 2 numbers. The sum value is 0. Carry is 1. Now the next step. How many numbers we are adding? 3, 2 original input values and 1 carry value. 3 bits. But can we add these 3 numbers using the half adder? Half adder is having only 2 inputs. The third input would have. So in that case we can't add. Actually half adder are not used anywhere. Applications of half adder are very less because of this reason. See, if you are adding in the mathematical algebra also, we are adding the again 2 numbers. For example, 223, 325. How many additions are there? 3 units. 3 no carry over chance of this, right? So in the series of additions, the half adder is not applicable. So for that, we are moving to the full adder circuit. Full adder. The full adder of the block diagram is full adder FA and the inputs are 3 inputs and the any adder having The results are only two results. Any adder, there is a 3-bit adder, or 4-bit adder, 5-bit adder, 10-bit adder, any adder having only the 2 input. The results are 2 outputs. Sorry, 2 outputs. That is the sum and the carry. Inputs can take any number, but outputs are only 2 outputs. So now this is the 3-bit adder. The 2 are input. What is the third one here? Carry and the C. Okay, the 2 are input and the third one is the carry. How can we add this using this full adder? Can we add this? Yes, because the 0 and 1 are the input and 1 is the carry. 1 you can apply here and A, B inputs can apply here. Okay, so that is the full adder circuit. Now, full adder can take the table A, B, C dash. C input, not dash. The outputs are sum and carry. What are the input combinations? Take 10 inputs and take all possible options you can take. Here, if the 3 inputs are there, we are not that is using the carry or not. We are using the 3-bit operation. The all possible combinations we are taking. That all possible combinations are 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Now we can add 3-bit addition here. 0 plus 0. ఇప్పుడు 3 బిట్స్ ఎలా యాడ్ చేయాలంటే ఫస్ట్ 2 బిట్స్ ని యాడ్ చేయాలి. ఆ వచ్చిన రిజల్ట్ సమ్ వాల్యూకి యు కెన్ యాడ్ ద థర్డ్ బిట్. క్యారీ సెపరేట్ పెట్టాలి. యు కెన్ రిమెంబర్ ఫస్ట్ 2 బిట్ అడిషన్ క్యారీ వచ్చింది అనుకోండి. ఫర్ ఎగ్జాంపుల్ 1 plus 1 ఇలా యాడ్ చేస్తున్నారు. ఫస్ట్ యు కెన్ యాడ్ దిస్ 2. వాట్ ఇస్ ద వాల్యూ? సమ్ 0 carry 1, right? For this sum you can add the third bit. Now 0 plus 1 carry alane petali. Okay, now can derive the table, complete the table. 0 plus 0 0, that 0 plus 0 sum 0, there is no carry. Next 0 plus 0 sum 0, that sum plus 1 there is no carry. And 0 plus 1 that 1 plus 0 1 0. Next 0 plus 1 sum 1, that sum 1 plus third one. What is the value? 1 plus 1 sum 0. Okay. This 0 plus 1 plus 1. First you can add these two numbers. What is the sum value? 1. And this one and this you can add, that is sum 0 carry 1, right? So the 0 plus 1 1 plus 1 0 and the sum 0 carry 1. Next 1 plus 0 1 plus 0 sum 1 carry 0. Pinadamma just 10 to 15 minutes ante lerante continue. So just you can attend to for the pay attention for the 10 minutes. Okay, one next 1 plus 0 1, that 1 plus 1 sum 0 carry 1. Next 1 plus 1 sum 0 plus 0 carry already present, that carry can write here. Next 1 plus 1 sum 0 carry is already present, sum 0, that 0 plus 1 sum 1 carry. Now we can write the expression for sum. Where for which input combinations we are having output is sum is the 1, and here and here. What is the input combination? A bar, B bar, C bar, A bar, B bar, C, A bar, B, C bar, A bar, B, C, A, B bar, C bar, A, B bar, C, A, B, C bar and A, B, C. What is the input combination? This A bar, B bar, C. Okay, now plus. What is the next input combination? We are getting the output is 1 under sum. Next A bar, B, C bar plus. Next one A, B bar, C bar plus A, B, C. How many terms are there? Many product are there. Okay, products. This is called the product and this is the sum. Now complete expression can be called as this is the product and this is the sum. That expression can be called as Emandrama. Tell me in terms of product and sum. You can give the one sentence for using the sum and products. What is that expression called? Sum of products. So in the Boolean algebra, the Boolean functions can be called as SOP and POS. This is not required for you. Just you can remember the POS SOP and the sum of products. POS product of sums. This is for the OR gates. So this expression is product of sum. Now that is the lengthier expression. Okay, now if you want to minimize, you can minimize. Ela minimize cheyali? How to minimize? Ela minimize cheyalama? Any common terms are there? You can take common. What are the common terms? ఇక్కడ A bar, B bar ఉంది, ఇక్కడ C ఉంది. నెక్స్ట్ ఇక్కడ ఏమున్నాయమ్మా? ఏమేం కామన్ చేయొచ్చు? ఓకే, ఈ రెండిట్లకి ఏం కామన్ తీయొచ్చు? A డాష్ కామన్ తీస్తే B డాష్ C ప్లస్ B C డాష్ ప్లస్ ఇక్కడ A కామన్ తీస్తే B dash C dash plus BC. Now you can write the simplified forms. A dash B C dash B dash C plus B C dash. What is the simplified expression? B plus right? A bar dot B XOR C plus B bar C bar plus BC. Right? Actually, this X NOR B X NOR C or B X NOR C ni B XOR C of the complement operation. Now, you can simplify it. This is the A. You can assume this is the B. A dash B plus A B dash. A XOR B. So what is the A here? The A is same. A XOR. What is the B? B is B XOR. The sum simplified expression is A XOR B XOR C, and similarly carry. So this is called carry. Can take a full word, or simply this is also called carry out. C out, C in another. C out, or simply carry out. Okay. For which input combinations the carry out is present? Here, A dash BC. A dash BC plus A B dash C plus A B C dash plus A B C, not dash. here also you can simplify or you can keep it as it is. Simplify చేయొచ్చా చూడండి. ఓకే, here ఈ రెండిట్లో ఏం కామన్ ఉంది? AB కామన్ ఉంది. నెక్స్ట్ ఇంకా ఇక్కడ ఓకే C కామన్. Now A dash B plus AB dash C plus take the AB common C dash plus C. What is the C dash plus C? What is the value? What is the binary value for C dash C plus C dash? What is the value? A plus A bar value. Achita C value any assign 0 or 1. 0 assign చేస్తే 1 0 వస్తుంది. 1 ఇక్కడ 0 1 అప్లై చేస్తే 0 1 వస్తుంది. సో 1 into AB AB. Now this can be ఇదేం రాయొచ్చు? A XOR B into C plus this is the carry expression. Now for this carry expression you can draw the logic circuit. Okay, now you can draw the logic circuit. This is our table. You note on the table. Table over. Table. Okay, now the logic circuit, how many inputs? A, B, C. On the first one, you can take the one XOR gate and 2 inputs. And this expression is A XOR B, and you can take the third input. And you can take the another XOR gate. Okay, so now this expression is A XOR B XOR C. Okay, now carry expression. Carry came on the A XOR B dot C plus A. So now here A so this is the, what is this? AB. A, B, then you can take the another AND gate. What is the AND gate? Inko AND gate entama? XOR output idi. And C. ఇక్కడ ఏమొస్తుంది A XOR B dot C. ఇది ఈ AND gate. Next one AB. So now I can join both with one OR gate. So this is the C out or carry out. చూడండి కనెక్షన్ ఎక్కడెక్కడ తీసుకున్నాం, ఎక్కడెక్కడ బైపాస్ చేసాము. కేర్ఫుల్. So using this full adder circuit, this logic circuit, you can apply the any 3-bit combination. Will get the correct output, correct sum, and the correct carry value for the any input 3-bit number. This full adder only using in the ALU unit, arithmetical logical operations. So in the logical and arithmetical logical operations to perform the addition, the same logic circuit. Designers are used, not the different. The same logic circuit. That's why but inbuilt of the CPU processor lo ALU untadi, arithmetic logic unit. Okay, so in the same logic they are implemented, and the computer also can perform the at a time only 2 numbers. At a time 2 numbers maatrame add avutadi. Manalagane mana kuda cheyagalama 5 numbers అనండి 5 + 4 + 3 + 2 అని అనుకోండి. ఫస్ట్ ఎన్ని నెంబర్స్ యాడ్ చేస్తారు? ఫస్ట్ 2 numbers. ఆ రిజల్ట్ తీసుకొని థర్డ్ దానికి యాడ్. థర్డ్ రిజల్ట్ యాడింగ్ టు ఫోర్త్ వన్. థర్డ్ రిజల్ట్ యాడింగ్ టు ఫిఫ్త్ వన్. The computer also can perform the same. First 2 bits. That sum is added to the third value. And third sum is added to the fourth value. And carry is forwarding. Carry forwarding. So this is about the combinational circuits. This is also the full adder also example for the combination circuit. ఇక్కడ ఇన్పుట్ అప్లై చేయగానే అవుట్పుట్ వస్తుందా లేక ఇంకా ఏమన్నా దేనికోసం అన్నా వెయిట్ చేస్తుందా? అది ఇన్పుట్ అప్లై చేయగానే we are getting the output. Such type of circuits are called combinational circuits. Okay. ఈ సమ్ ఎక్స్ప్రెషన్ రాయనమ్మా, ప్లేస్ లేదని రాయలేదు. సమ్ ఎక్స్ప్రెషన్ with carry expression this for the circuit diagram. The next topic is the sequential circuits. In this combination circuit, any feedback is there? Feedback అంటే output to input. Is there any connection between the input circuit and output circuit? No. Directly we are applying the input and we are getting the output. There is no feedback from output circuit to input circuit. That circuits are called combinational circuits. If feedback is there from output to input, that circuits are called sequential circuits. మీకు మెమరీ ఉందా? ఫోన్ లో మెమరీ 4GB RAM, 20GB RAM, 64GB RAM. That memory devices are designed using the next sequential circuits. Okay, so now we are using the 1-bit memory element. And the 1-bit binary value. Binary is either 0 or 1. So to hold that value, we are using the 1-bit storage devices. That is in sequential circuits. Now sequential circuits. The block diagram of sequential circuits are inputs, and outputs, and similarly we are using feedback also. Feedback, and this feedback devices are called memory elements. These feedback devices are called memory elements. So now, ante vache output ni we are connecting to the input circuit. And one more point here, the difference between the combinational circuit and the sequential circuit, the feedback is not present in the combinational circuits. There is the one difference, and the other one is the feedback is present here. Coming to the combinational circuit, the output can be reflected whenever the inputs are applied. Coming to the sequential circuit, the output will be reflected whenever the triggering pulse is applied. Other than input, apply chesnarani. If you are not applying the triggering pulse, triggering ante activate cheyadam. Ikkada maatladutunna mic off lo unte emautundi vinapadu ade kada. So adi triggering kaadu, adi power on. But here input unna gani the circuit is not triggered, not activated, then the output will not generated in the presence of inputs also. That circuit is called sequential circuit. Okay, now this memory elements we are using as flip-flops as the memory elements. The flip-flops as memory elements, and these flip-flops are 1-bit storage devices. The flip-flop can hold the 1 bit of information. Okay, the flip-flop is having is the 1 bit storage device, and the flip-flops are required the triggering pulse, clock pulse. Clock తీసుకోండి. Clock అంటే watch కాదు. Square wave. This is the 0 and this is the 1. దీంట్లో ఎన్ని లెవెల్స్ ఉన్నాయమ్మా? ఎన్ని డిఫరెంట్ షేప్స్ ఉన్నాయి దీంట్లో? This is the 1 అంటే 0 నుంచి 1 కి వెళ్తుంది. ఓకే, దిస్ ఈజ్ కాల్డ్ 1 ఎడ్జ్. ఇది ఒక పీరియడ్ అంటాం దీని. ఇక్కడికి ఒక పీరియడ్ అంటే ఇంత పీరియడ్ లో తీసుకోవాలి ఎప్పుడైనా. అంటే ఇక్కడ సపరేట్ డిఫరెంట్ ఫేస్, ఇక్కడ డిఫరెంట్, తర్వాత రిపీట్ అవుతుంది. సో దట్ ఈస్ కాల్డ్ ద 1 పీరియడ్. సో విత్ ఇన్ దట్ పీరియడ్ ఇది ఒకటి 0 నుంచి 1 కి రైజ్ అవుతుంది. ఇది లెవెల్ ఉంది 1, అండ్ హియర్ ఫాలింగ్, అండ్ హియర్ అంటే ట్రిగ్గరింగ్ అనేది యూ కెన్ అప్లై ద ఎనీవేర్. అంటే ఈ క్లాక్ పల్స్ అప్లై చేసినప్పుడు ట్రిగ్గరింగ్ based on the designing of that flip-flop memory element, so that can be triggered at this time or here or here or here. అంటే ఈ క్లాక్ పల్స్ అప్లై చేసినప్పుడు క్లాక్ పల్స్ లో ఎప్పుడైతే రైజింగ్ ఎడ్జ్ వస్తుందో, దిస్ ఇస్ కాల్డ్ ద ఎడ్జ్, ఫాలింగ్ ఎడ్జ్, రైజింగ్ ఎడ్జ్. ఓకే, ఈ ఎప్పుడైతే ఈ ఎడ్జ్ వస్తుందో అప్పుడు ఇన్పుట్స్ ఉంటే దట్ కెన్ గివ్ ద అవుట్పుట్. సో దట్ circuits are called sequential circuits. Now the different types of sequential circuits are there. All flip-flops and counters, registers. What is the register? The register is a collection of flip-flops. What is the flip-flop size? 1 bit. For example, register name sinara. Okay, integer. What is the integer size in the C language? Integer. Data types nahi kada. Data types. What is the size? 2 bytes. What is the in terms of bits? How many bits are equal to 1 byte? 8 bits. Collection of 8 bits is equal to 1 byte. 2 bytes is equal to 1 word. 16 bits. Okay. So now, if you want to design the 1 byte memory, 1 byte register, అంటే డేటా టైప్ అంటే ఏంటి? అక్కడ రిజిస్టర్ అనేది ఇంటీజర్ అంటే ఏంటి? ఆ ఏ అనే ఇంటీజర్ ని we are assigning to one register. That register capacity is 16 bits. అంటే 16 bits అంటే ఎంత వాల్యూ ఎంత, రేంజ్ ఎంత? What is the data type range for the integer? 16, 0 to 2 to the power 16 minus 1. వాల్యూ చేసుకోవచ్చు. 2 to the power 16 వాల్యూ ఎంత? 65,536 ఏమో, 536. Okay, 0 to, so we can accommodate for the integer range value. Data value is 0 to 65,535 in decimal. Beyond that, we can't assign for the integer value. Then we can use the double or long int. And similarly, here the flip-flap is the 1-bit storage device, but in the C language or in other computers, here is the size is the more. So that means you can how many bits you require, you can connect that many flip-flap. Integer 2 times enough, 2 bytes enough, and then 16 bits. So we can use the 16 flip-flaps. You can design the 16-bit register. Okay, the register is the collection of flip-flaps. Any collection cheste anta size is 4 flip-flaps use cheste, that is the 4-bit register. Okay, and 5 concat cheste, that is the 5-bit register, and 8 cheste 8-bit, 16 cheste 16-bit. Okay, now these flip-flaps are the different flip-flaps are there. One is SR flip-flap, JK flip-flap, and D flip-flap and T flip-flap. The 4 flip-flaps are there: SR, JK, D, and T flip-flaps. These all are the example for the sequential circuits. Now you can take the SR flip-flap. See this each flip-flap is having its own circuit, logic circuit, and its own truth table. The truth table is nothing but the truth table is derived from the logic circuit only. The truth table అంటే ఏంటి? Inputs ఉంటాయి, outputs ఉంటాయి. Binary values inputs, binary values outputs. That is called the truth table. Okay, the truth table is derived from logic circuits only. Okay, so for this logic circuit is now the flip-flap is having the 2 inputs S and R, where the S stands for set and R stands for reset. Set and reset and set and set means 1, reset means 0. Set means 1, reset means 0. Okay, reset చేయడం అంటే సర్క్యూట్ 0 చేయడం, సెట్ చేయడం అంటే 1 అప్లై చేయడం. ఓకే, నౌ టైం అయిపోయిందా? ఇదొక్కటమ్మా, ఇదొక్కటి జస్ట్ ట్రూత్ టేబుల్ I will draw. Yes, R. Now here just I will draw the circuit. You can go for the later. Feedback unda దీంట్లో సీక్వెన్స్ సర్క్యూట్ ఫీడ్బ్యాక్ ఉందా? ఫీడ్బ్యాక్ మనం ఇన్పుట్ అప్లై చేస్తున్నాం కదా, దట్ ఇస్ ద QN. అంటే along with the inputs, if you are connecting the output to the input, that is the called present state. Present state ante, and this is next state. The present state and next state. Now we can take the inputs 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1. The present state may be 0, 1, 0, 1, 0, 1, 0, 1. Table ద్వారా చెప్పాలా డైరెక్ట్ చెప్పాలా? సర్క్యూట్ చెప్పాలా డైరెక్ట్ చెప్పాలా? Okay. Set and R value both are 0. ఇది present state. అంటే present state అంటే ఏంటంటే ఇక్కడ ఉన్నారు. ఓకే, అవుట్పుట్ తీసుకొచ్చి ఇక్కడ అప్లై చేస్తున్నాను. ఇన్పుట్స్ ఉన్నాయి అంటే ప్రీవియస్ అవుట్పుట్ ఉంది కదా, ఆ ప్రీవియస్ అవుట్పుట్ కి present inputs కి అప్లై చేసి వచ్చే అవుట్పుట్ ఇస్ ద నెక్స్ట్ స్టేట్. మనం ఇన్పుట్స్ తో పాటు ఏదైతే అవుట్పుట్ అప్లై చేస్తున్నామో ఇన్పుట్ గా దట్ ఈస్ ద ప్రెజెంట్ స్టేట్. ఓకే, నౌ 0 0 ఉన్నప్పుడు అవుట్పుట్ ప్రెజెంట్ స్టేట్ 0 ఉంటే ద అవుట్పుట్ ఈస్ 0. 0 0 ఉంటే అంటే ఏంటి, ఇక్కడ ప్రెజెంట్ స్టేట్ 0 ఉంది, నెక్స్ట్ స్టేట్ 0 ఉంది, బోత్ ఆర్ సేమ్, దట్ ఈస్ కాల్డ్ నో చేంజ్. అంటే మిషన్ ఈ స్టేట్ లో ఉంటే 0 0 అప్లై చేసినప్పుడు అది ఏం కదలట్లేదు. 0 లో ఉంటే 0 లో ఉంటుంది, 1 లో ఉంటే 1. సో దట్ మీన్స్ నో చేంజ్. రైట్ ద ఫుల్ వర్డ్ నో చేంజ్. నౌ ఇక్కడ r వాల్యూ 1 ఉంది. r అంటే ఏంటి? r stands for reset. So r is equal to 1 and s is equal to 0. The present state is 0 0 1 0. అంటే ఏంటి, ఇక్కడ 0 1 ఇన్పుట్ టు SR అప్లై చేసినప్పుడు irrespective of the previous output that will be reset. Okay, next here 1 0 ఉంటే 1 1, the set value 1 ఉండి r 0 ఉంటే the irrespective of the present state the output will be 1. So this is called set and this is reset. And the next one, this 1 0 here 0 card. This is the main drawback of the SR flip-flop is that if s is equal to 1 ఇక్కడ పాసిబిలిటీ ఉందా, s is equal to 1 r is equal to 1 ఉన్నప్పుడు 0 ఉంటే x x అంటే ఏంటి, ఇక్కడ invalid. Okay, this is the truth table of the truth table derived from this one only. If work unte I will explain this process. Okay, so this is, and similarly the one more gate, one more flip-flop jk ఏంటంటే సేమ్, ఇది సేమ్ ఉంటుంది, ఇది సేమ్, దిస్ వన్ సేమ్, బట్ ఇది ఒక్కటి మాత్రం చేంజ్ అవుతుంది. ఏంటంటే అది 0 ఉంటే 1 అవుతుంది, 1 ఉంటే 0, అంతే డిఫరెన్స్. The t and d is not required for. The d can be derived from SR flip-flop and t can be derived from JK flip-flop. Okay. Now, in the last class, one topic is left. That is the what is the? I will just 2 minutes. Public address system. Explain the blocks. Just orally I will explain. Explain the public address system. అంటే స్టేజ్ మీద పెట్టి మైక్ పెట్టి మాట్లాడుతుంటే పెద్ద సౌండ్ వస్తుంది కదా, లౌడ్ స్పీకర్ లో పెట్టి హౌ దట్ లౌడ్ వాయిస్ ఇస్ ఇంక్రీజింగ్. ఫస్ట్ ఏం చేయాలంటే ఐఎమ్ స్పీకింగ్ నౌ, దట్ ఈస్ ద విచ్ టైప్ ఆఫ్ సిగ్నల్. నేను మాట్లాడుతున్నాను కదా, నా నోట్స్ వచ్చే సౌండ్ విచ్ టైప్ ఆఫ్ సిగ్నల్, మెకానికల్ ఆర్ ఎలక్ట్రికల్? మెకానికల్ సౌండ్ సిగ్నల్. నౌ అదేం చేయాలి మనం సౌండ్ సిగ్నల్ ని? నేను మాట చూపిస్తుందా అంటే చిన్నవి అదే మైక్ పెట్టుకుంటే అంటే మన మైక్ ఏం చేస్తుంది, అది యాంప్లిఫై చేస్తుంది. నౌ సో పవర్ ను ఇంప్రూవ్ చేయాలి, రైట్? సో ఫస్ట్ ఏం చేయాలి, ఆ వచ్చిన సౌండ్ సిగ్నల్ ని we need to convert, amplify చేయడానికి పవర్ ఇంప్రూవ్ చేయాలంటే ఏం చేయాలి? That is called the electrical signal. First ఏం చేయాలి, mechanical signal ni or the sound waves ni we need to convert into the electrical signal. The electrical signal is having power, that is voltage and current. The voltage can be improved using the pre-amplifiers. Pre-amplifiers. The pre-amplifiers are increasing the voltage levels. Voltage increases, the current will increase. What is the P? Power P is equal to PI. Voltage into current. And voltage is the current will pencil. Both are proportional. Okay. That current can be improved using power amplifiers. Okay, the pre-amplifiers can be improving the voltage level, that equivalent voltage level current also we need to improve, that is the power amplifier. Okay, using the power amplifier the signal is improved in the current also. Now the total power is improved again. So which type of signal we are improved, amplified, electrical or sound signal? మైక్రోఫోన్. ఈ మైక్రోఫోన్ is sound wave వస్తుంది. ఆ sound wave we are connecting to the preamplifier. That preamplifier is improving the voltage level. Then power amplifier. That power amplifier is improving the current levels. And now we are improving the voltage levels and the current levels. Then we are connecting that to the loudspeaker. Loudspeaker ka namunde untundi. That amplified signal or can be converted to the electrical to sound signal, and that sound can be listening through the loudspeakers. So that is the public address system. Next, other topic is the instrument block diagram of instrumentation. అంటే ఇన్స్ట్రుమెంటేషన్ అంటే ఏంటమ్మా, ఒక వాల్యూ ఏంటి, మీకు మొబైల్ ఫోన్ ఉంది, దాంట్లో మీకు టైం చూడాలంటే టైం వస్తుంది, లేదంటే వెయింగ్ మిషన్స్ ఉన్నాయి, చూసారు కదా కిరాణా షాప్ లో వెయింగ్ మిషన్స్ అంటే డిజిటల్ వెయింగ్ మిషన్స్ వచ్చాయి. ఎలా పనిచేస్తుంది అది, ఒక వెయిట్ వాళ్ళు పెడుతుంది దాని మీద, ఆ వెయిట్ ఏంటది మెకానికల్ ఎనర్జీ. ఆ మెకానికల్ అంటే ఎంత వెయిట్ ఉందో ఆ మెకానికల్ ఎనర్జీ దట్ మిషన్ ఇస్ కన్వర్టింగ్ ఇంటూ ఎలక్ట్రికల్ సిగ్నల్ and equivalent electrical signal. That equivalent electrical signal is processing and giving the equivalent values, and that electrical signal again converted to the digital form. So digitally that is this thing, that is the basic instrumentation system. Okay, so this is about my lecture. If you are having any queries, you can ask. And if you want, you can say your opinion on this today's lecture. Your views and opinions on today's lectures. Huh? I think different dilemma. You can say, you can మీ ప్లేస్ నుంచే నిల్చొని మాట్లాడచ్చు. ఇప్పుడు నా టైం అవుతుంది, మీకు టైం అవుతుంది 3:40. Okay, the conclusion, you are in this today's lecture, are you happy? Is it helpful for your exams and your career?
Yes, sir.
If you want to say personally, you can come and you can share your views personally also. If you are saying we can maatladడానికి ఇబ్బంది ఉంటే you can come personally. Okay, thanks for bearing up 2 hours, 2 days of sessions. Okay, thanks.